This is a short presentation video for my bachelor thesis on model-based generation of a GraphQL infrastructure. MontiGEM is a generator for enterprise management systems that is being developed at the chair of software engineering. It uses concepts from model-driven software engineering to support strong stakeholder involvement and to improve development time. In MontiGEM, the domain model contains textual class diagrams describing the application's data structures, like the database entities. Using this model, the generator produces source code for front-end and back-end, which then works together with handwritten code files to form the working application. Currently, data communication between front-end and back-end is handled by a generated command API, which, for example, allows the front-end to request all objects of a certain type or individual objects by ID. The data querying capabilities of this command system are very inflexible and limited, so in this thesis we introduce a generated GraphQL API as an alternative for data fetching and manipulation in MontiGEM. GraphQL is a query language for client-server data communication. The client sends a query that describes the shape of the desired data. The server then responds with data that structurally matches the query. On the server side, the schema defines which queries are possible using GraphQL's schema definition language. In order to realize a generated GraphQL infrastructure for the MontiGEM domain entities, we extend the generator in two ways. First, we generate a schema for our GraphQL API. This involves transforming the domain class diagram into a set of GraphQL type definitions. We also generate additional derived types to enable advanced querying features like restriction, ordering, and grouping. Second, we generate Java classes that implement the necessary backend logic to power our API. These work together with the open source GraphQL Java runtime engine and our generated schema to enable the fully functional GraphQL API. In this example query, we request a list of user objects. On those objects, we select the fields ID and username. We further provide arguments that the list should only contain activated users. Additionally, we specify that users should be ordered by registration date and limited to 4 results. Advanced querying features like these make our GraphQL API very flexible, covering many common use cases. As a result, developers can use the generated API more often as opposed to creating and implementing custom data fetching commands. GraphQL itself is gaining in popularity as a web API technology, with a growing number of tools like GraphQL IDEs, which make writing and debugging queries very easy. Future work could include integrating GraphQL into GUI DSL web page definitions and implementing role permission-based authorization for GraphQL queries. Thank you for watching.